Alright guys, here we go. We got another one. This video is dedicated to all you guys who are trying to get that A. Happy Valentine's Day. Oh, letting me know that I have a game, I guess. Alright, anyways, let's just do this, take care of business here. I think you're going to like it. Let's get right into it. So it says calculate the integral of secant squared 6x tan 6x plus 2. So the way you do that, let me make sure that we're recording here. Yeah. The way you do that is you have to do u substitution, guys. So make a relationship. So we notice there's a secant squared on the top, and we notice there's a tan x on the bottom. So if I make u equal to tan x, tan of 6x specifically, plus 2, then du is going to be secant squared of 6x times 6 dx. So what am I missing? So let's see, it's missing a 6 here. And if I put a 6 there, I got to put a 1/6 to balance. So there we go. So 1/6 integral 1 over u du. Antiderivative of that is ln, absolute value of u, plus c. Plug in back what c is. So ln tan of 6x plus c. 6x plus 2, by the way. Plus c. And there it is. Let's go to the next one, guys. So you got to look at it and you got to recognize something. So I see an ln and I see a 2x plus 6 in the bottom. So I recognize that if I set u equal to ln of 2x plus 6, then du is going to equal 1 over 2x plus 6 times 2 dx. So let me rewrite it. 2 over 2x plus 6 dx. I'm kind of tempted to factor out a 2 in the bottom, but I'm going to leave it in there for now, guys. So I'm going to leave it in there. So now I have this. I have integral, and I have, let's see, I don't have 2x over 7. I'm going to insert a 2, put a half on the outside. So I have a half, and I have tan of u du. And I know what you're thinking. You're thinking, all right, Chavez, now I'm here. Now what? We're going to do another u sub. We're going to say that w equals, so let's see, let's rewrite this. I'm going to rewrite this as sine of u over cosine of u du. And I'm going to say that w equals cosine of u cosine of u. So then that means that dw equals negative sine u du. And look, there it is. So I'll put a negative, and let's see what's going to happen here. I'm going to rewrite it here, guys. Antiderivative, so negative 1/2 integral of, let's see, negative sine u du is dw. So 1 over u dw, 1 over w dw. Antiderivative, negative 1/2 ln of w plus c. W was cosine u. So negative 1/2 ln of cosine u plus c. And then what was u again? U was all this right here. So negative 1/2 ln of cosine, what was u? ln 2x. ln 2x plus 6 close plus c. And you're looking at it and you're probably like, Chavez, I don't see any of those answers. Okay, that is because, okay, side note real quick right here. So side note, if you have negative ln of cosine inside, that's going to be the same. So let's see. If I say ln of 1 over cosine, which is secant, remember that ln of 1 over cosine is equivalent to saying ln of 1 minus ln of cosine. And ln of 1 is 0, So notice that you're seeing, here I have a negative ln of cosine x, and look, negative ln of cosine x. So ln of secant is the same thing as negative ln of cosine x. So that's a side note, guys. Ln of secant x. So negative ln of cosine x is equivalent to ln of secant x. So this is my answer with the negative in it, and notice that I don't have a single answer that says negative. So it's that one in terms of secant. So I hope that made sense to you guys, that if I write it in terms of secant, you can take out the negative there. ln 2x plus 6 plus c. All right, let's go to the next one, guys. This one's a prime example for u sub. I would just do u sub immediately. Excuse me. U equals x squared minus 2. du equals 2x dx. Put a 2 in there, put a half on the outside to balance, and here we go. So write 1/2 integral 2x dx is du, so 1 over u du. Now I need new limits. When x is 3, 3 squared is 9, 9 minus 2 is 7, so I put a 7. When x is 7, 7 squared is 49, minus 2 is 47, so we're at 47. So here we go. 1/2 bracket, antiderivative is ln of u, close it from 7 to 47. And the reason why I have the half on the outside, guys, is because I like to have it factored out. It's easier in my opinion. So then ln of 47 minus ln of 7. Notice I'm no longer putting the absolute value because those are positive numbers. So this becomes 1/2 ln of 47 over 7. All right, this one here, question 4, is another example of u sub. So make u equal to 4 plus sine x. So du is going to be equal to cosine x dx. So it's perfect. Integral 1 over u du. When so here comes the unit circle, guys. When x is pi over 6, sine of pi over 6 is a half. So 4.5, what's that, 8, 9/2, so 9 over 2. And then when x is pi over 2, sine of pi over 2 is a 1. And sine of, so 4 plus 1 is 5. So there's my new limits. So here we go. Let's see, ln absolute value of u. And I'm going to evaluate this from 9 over 2 to 5. So it's going to be ln of 5 minus ln of 9 over 2. So then this becomes ln of 5 over 9 over 2. So that's like 5 over 1, guys. Keep, change, flip the 9 over 2. So 2 times 5. So my final answer is ln of 10 over 9. 10 over 9. Yay. I hope you guys are liking these. All right. A particle moves along a line with acceleration a of t. Find the distance traveled by the particle during the time 0 to 1. Give the initial velocity v of 0 is 1/3 p per second. Okay, maybe we'll need this guy, maybe we won't. It says distance traveled, so it's the absolute value of velocity. So we're going to have to do antiderivative of that. They're being nice to us. It's pretty easy to find this antiderivative, guys. So notice I have a negative. So this is like saying negative 1 over x squared. So it's like x negative, x to the negative 2. So if I take the antiderivative, you add 1 and divide by that. So x to the negative 1 divided by negative. Negative divided by negative is a positive. So this is 1 over t plus 3 to the 1 power. Now notice it says v of 0 equals 1/3. I don't have to do anything, guys, because if I plug in a 0 for t, I do get a 1/3. So it checks out. That v of 0 definitely is 1/3. This is what I'm integrating. So I'm going to take the integral. 1 over t plus 3 is always positive for t values larger than 0, and they are. So I don't have to worry about that. So I'm going to integrate from 0 to 1 of 1 over t plus 3 dt. So that antiderivative, since t is to the 1 power, that has to be an ln. So it's ln of t plus 3. And I'm evaluating this from 0 to 1. So plug in a 1. ln 1 plus 3 is 4. Minus ln 3, And the way they wrote it, this ln of 4 can be written as 2 squared. And 2 squared, you can bring the 2 to the front. So 2 ln of 2 minus ln of 3. So there it is. All right, explain why the formula ln x minus 3, 108 equals ln of 5 is not correct. Okay, it's simple, guys. Notice this function here is 1 over x minus 3. Notice the interval is from 1 to 8. You cannot integrate this function because at x equals 3, you can't integrate. You have a vertical asymptote. So you're undefined at x equals 3, guys. So you can't integrate over where you're not defined. So the integral is not defined at x equals 3. You have to be defined to find the area under a curve, guys. All right, let's go to the next one. All right, so at first glance, this one looks hard. But notice, you got to observe, this e to the negative 3x is giving you a huge hint. So u must be 4e to the negative 3x. Why? Because du is going to be, let's see, 4, leave some space, e to the negative 3x times negative 3 dx on the side. So du is going to be equal to negative 12 e to the negative 3x dx. And I know what you're thinking. You're like, okay, Chavez, how does that help me? Well, that's a negative exponent. So I can rewrite that as negative 12 over e to the 3x dx. And notice, I don't have a negative 12, but I have an e to the 3x dx. E to the 3x is in the bottom with the dx there on the side. So I'm going to insert a negative 12. I'm going to put a negative 12 right here. And then I put a negative on the outside, negative 1/12. And now I'm ready to go. So here we go, negative 1/12 integral sine of u du. Perfect, I'm ready. Antiderivative of a sine is negative cosine. I put a parentheses to indicate that I'm multiplying negative times a negative, and I put the plus c. And now I just go ahead and multiply. Negative times a negative is a positive. So 1/12 cosine of u, which is 4e to the negative 3x, plus c. There it is. All right. This one, they're pretty much making fun of you right now. That's just arc sine. Look, there's no u sub anywhere. Pull the 2 to the outside. Integral 0 to square root of 2 over 2. 1 over square root of 1 minus x squared dx. Look at that. Perfect. That, the derivative of arc sine is 1 over square root of 1 minus x squared. So the antiderivative must be the same. Keep the 2. Arc sine of x. I'm going to evaluate this from 0 to the square root of 2 over 2. I'm going to leave the 2 factored out. So there it is. Giant parenthesis. Arc sine of square root of 2 over 2 minus arc sine of 0. So here we go. 2 times arc sine of square root of 2 over 2 is pi over 4. Minus arc sine of 0 is 0. Well, 2 times pi over 4 is pi over 2. Yeah, they're making fun of you guys. Don't let them offend you. I'm offended. No, I'm not offended. Oh, look, another one. Okay, this is not u substitution at all, guys. Do not say u equals x squared plus 9, because then du would be 2x dx, and there is no x that you can substitute. This looks a lot like arctan to me. So if you remember, the derivative of arctan, let me write this here on the side, d dx, this is a side note, is 1 over 1 plus x squared. Or I guess if I would have written a u, it would have been 1 over 1 plus u squared du dx. So the only thing that is stopping this from looking like arctan is that number right there. So what do? Well, what you do is you force it to be a 1. And I do that by dividing by 9. Now this is magic. You can't do magic, so you got to balance everything out. Divide by 9, divide by 9. So there it is. Everything is balanced out. Everything is divided by 9. Maybe I'll use the 1/9. We'll see. So before you pull it out, don't pull it out just yet. So let's see what I have. 1/9 over 1 plus parenthesis x over 3 with a square on it. And this is all dx. Okay. Now you can probably pull out 1/3 of the 1/9, or like, yeah, because 1/3 times 1/3 is 1/9. So what I'm trying to tell you is that u is going to be x over 3. So du is 1/3 dx. So I have 1/3 too many if you say 1/3 times 1/3. So I'm going to say 1/3 here and 1/3 there. So see, 1/3 times 1/3 is still 1/9. I hope that makes sense to you guys. I really do hope that makes sense. So 1/3 integral 1/3 dx is du. 1 plus u squared du. I need new limits. So let's see. When x is 0, u is 0. And when x is 3, u is 1. All right, we're ready. 1/3 arctan of u from 0 to 1. There's no reason to go back to x. Don't go back to your x's. There's no reason to go back to your x, and there's no reason to go back to x in this case. So it's both true in real life and in math. So don't go back to your x. So here we go. 1/3, leave it factored out, arctan of 1 minus arctan of 0. Well, hopefully you guys had a super awesome pre-cal teacher, and I know you guys did. Arctan of 1 is pi over 4, because at pi over 4, the x and y coordinate are both the same value. And arctan of 0 is 0. So there it is. And I'm going to multiply pi over 4 times 1/3. So 3 times 4 is 12. So I get pi over 12. Yay. Happy face. All right, let's go to the next one. This one looks like, so here's the hint, e to the 2x, and I see e to the 4x. So this looks like it's going to be an arctan to me. So why do I say that? Because I guess it could also be an ln. What? Nope, it has to be an arctan. So here we go. I'm going to rewrite it, guys, so you guys can see it. Integral e to the 2x over 1 plus e to the 2x, close it, put a square on it, dx. See, this looks a lot like 1 over 1 plus x squared. Do you guys see that? If I set u equal to e to the 2x, du is going to be 2 e to the 2x dx. Now, I don't have a 2 e to the 2x. I have an e to the 2x. So here we go. I'm going to plug in a 2, and I'm going to plug in a half to balance it out. So now we're good. All right, 1/2 integral 1 over 1 plus u squared du. So I need new limits now. When x is 0, e to the 0 is 1. And then when x is ln 4, so I'm going to have to do this here on the side, e to the 2 times ln of 4, bring the 2 back in there, e to the ln of 4 squared, which is 16. E and ln cancel each other out, and you get 16. So the upper limit is 16. So now we're ready. 1/2, and this is arctan. Arctan of u, and again, no reason to go back to your x. You're going to do those. So upper minus lower, keep the half factored out. So I'm going to keep the half factored out, and I'm going to go arctan of 16 minus arctan of 1. Arctan of 1 is pi over 4, because again, the x and the y have the same coordinate there, or same magnitude value there. So I'm just going to distribute the half there. So I'm going to have 1/2 arctan of 16 minus, and then 1/2 times pi over 4 is pi over 8. That's an 8. It just came out dumb. And there it is, guys. All right, let's keep going. This one is a prime candidate for x squared, and look at the hints. It is going to be an inverse. So it looks like that's x to the 4, so I'm going to have to change that to x squared, guys, because arc sine is 1 over the square root of 1 minus x squared. So here we go. I'm rewriting it. And let me put it in blue so we don't confuse my fans here. Integral 12x over square root of 1 minus, open parenthesis, x squared squared dx. So u is going to be x squared. Du is going to be 2x dx. I need a 2x dx. So factor out a 6 from this. So if you put a 6 on the outside, then you can put a 2 there. So there it is. 6 times 2 is still 12. There was no need to really balance it out too much. So now we're good. So 6 integral 1 over the square root of 1 minus u squared du. So we have 6 arc sine of u plus c. And then we're just going to plug in what u is. U is a star. U is smart. So just plug in that u, guys. X squared plus c. And there it is. Yay. Oh, wow. We finished that one pretty quick. All right, guys. I hope you guys had a good time. Thumbs up. I hope you liked this video. And shout out to you guys. I hope you guys are doing awesome. All right. Take it easy, guys. Later. Bye.